A lot of Americans use fertilizer for their front lawns. My dad is one of these Americans. One day, after taking a dead tree out of our backyard, we had to fill up the hole. And after filling it with topsoil, we put the grass seed on and some starter fertilizer. Then I was wondering if the starter fertilizer was really necessary for the successful growth of the new grass. So for this experiment, I used cups to hold the plants in, as well as Pennington grass seed, which is kind of obvious that I would use this because, well, you need seeds to grow grass. And I also use Scott's topsoil as just the regular soil, and Scott's starter fertilizer as my fertilizer. So what I did was, first I poked holes in the bottoms of the cups. This allowed for any excess water in the plants to go out of the bottom of the cup instead of overflowing over the sides, and keeping all the seeds and the fertilizer inside the cup and preventing it from going outside the cup, which would ruin everything. So after I did that, I filled it with dirt, with the topsoil, and put the seeds in it. And after I did this, I put fertilizer in half of them. I put fertilizer in the ones on the right half, and the ones without fertilizer are on the left side. So I left the plants out for 2 weeks while recording the height and color every day. Now, I recorded the color just to make sure that they weren't dying and that they were healthy. So in the first trial, my data was a bit different than from what I expected, as the plants without fertilizer did essentially just as well as the grass with fertilizer. And I was wondering why this happens in my trial. In the second trial, something really weird happened which surprised me. The plants without fertilizer did really well. A lot better than I would expected, and did a lot better than the grass with fertilizer. Now, one of the reasons why the plants with fertilizer did a bit worse was because they germinated a bit later. Now, this was my fault because I miscalculated where the shade would be on my deck, and so they weren't exposed to as much sunlight and therefore as much heat as the plants without fertilizer, which didn't leave the plants with fertilizer in a warm enough temperature for a long enough period of time for a successful germination. Now, that aside, the plants grew pretty well once they came out, basically at the same rate as the plants without fertilizer, which is pretty good. But as you can see, in the plants without fertilizer, towards the end over here, the graph starts to level out a bit. And I was wondering why this happened. Why it just suddenly stopped growing, not nearly as fast, whereas the grass with fertilizer just kept going at the same steady rate. Now, when I looked at the averages, this is what shocked me most. The grass without fertilizer did better than the grass with fertilizer. And I was wondering why this happened. And after thinking about it, I realized that fertilizer is just really nitrogen and phosphorus, which is essential for the healthy growth of plants, as are needed in many parts of the cell, such as proteins for nitrogen and, say, the membrane for like phospholipids and stuff. Well, and then I looked at the back of the Scott's topsoil and said they had nitrogen and phosphorus in it. So then when I thought about it, I realized that the nitrogen and phosphorus already present in the topsoil was enough to sustain a successful plant growth in the first 2 weeks, for the grass without fertilizer, and so the fertilizer wasn't really necessary at this point. But as you can see, towards the last 3 days, it starts to level out a bit, and this is because the nitrogen and phosphorus levels started to lower, which caused the plants to not grow as fast, whereas the plants with fertilizer just kept at the same steady rate, because if there wasn't enough nitrogen and phosphorus, the fertilizer would just help with that, giving it enough nutrients for a steady growth. And so in conclusion, fertilizer is not really necessary in the first week or two of grass growth, as there's already enough nitrogen and phosphorus in the soil to sustain the grass.